we're going to take a look at this last problem here for the Clojure exercises for Summer of S expressions. I finished Leap a while ago, twofer as well. Recently did difference of squares and robot name. So now we're going to take a look at matching brackets. So let's download that exercise. Oops. Okay, so it should be called matching brackets. It's an apt exercise because Clojure is all about, or in Lisp you got all these parentheses, and so you typically use IDE tools that make sure that all of your brackets are balanced at all times. So go to matching brackets. Okay. And we will open up matching brackets and open up README as well. Okay, so what do we need to do? We need to, given a string containing brackets, braces, parentheses, or any combination thereof, verify that any and all pairs are matched and nested correctly. So, according to this page, it also says using recursion to process a string. So we'll figure this out as we go. So presumably we're going to get this string here, and it's going to check to see if it's valid or not. So basically, this is saying using recursion, you could do it, but essentially you want to loop over each character in the string and possibly use like a stack. So if you see an open parentheses, push it down to the stack, and then as soon as you see a closing one, you pop it back off again. And when you reach the end of the string, your stack should be empty. If it's not, then it's not a valid string. So that's my idea of how to solve this. We'll get started with that. So let's say, how do we loop over the string? Clojure. Okay, we'll do this. Let's see. How can I loop over the characters in a string in Clojure? There we go. Go back there. You can use a for loop to iterate over the characters in string Clojure. Here is an example. The string takes a string as input and returns a sequence of characters. The for loop iterates over each character in the string and returns as an element of the sequence. For CSC. Okay, let's see if that's actually true or not. Come over here and we'll do hello. I'm pressing Alt-Enter there, and it's printing out each character. So that's true. Okay. So this is saying using recursion. That for thing is pretty easy to use there. But let's see if there's a recursive way of doing it. We don't have to do it recursively, but let's see. Great. How can I do that using recursion instead? Alright. If not, this will be pretty good as well. So for each one, we'll essentially push or pop to the stack. Loop over string if MTS nil, do print line first S, loop over string rest S's. First and rest, essentially is what they're doing. can I pattern match to get the first and rest of the string? So here they just use first and rest there, but I'm curious if there's actually a way to pattern match instead. Yes, you can use pattern matching to get the first and rest of the string in Clojure. Here's an example. If empty, let first char and rest. S. Okay. So let's take a look at that. We'll just say first char and rest of hello. Oops. Let's see. Control Alt comma is what I pressed there. Syntax error. First char and rest doesn't like that. Okay, let's just copy this and paste this over and see how well that works. Okay, so evaluate that. Hello. Well, it's just doing a print line. I don't know if it actually put it in the REPL or something. Let's recheck in anyway. Checking in, line engine, starting REPL. Did I run into an error? Oh, here it is. Okay. Check in done. Let's give this a try. So if I press Alt Enter here again, Alt Enter. Oops. Syntax error compiling this. Let's try that again. Alt Enter. Okay, so now it's running into a syntax error. That's no fun. Alright, well, I guess the nice thing about the recursive thing is if we do this for loop, keeping track of the stack would require a mutation. Okay. Let's do it with a helper function first, and then I think there's a way to do it without actually using a helper function, but we'll do it with a function, helper function. So we'll say defn, and we'll say, what do we want to be doing? We want to be going over each character, magic brackets, string, let brackets for C, string, print line brackets. That's not what we want anyway. We want to, if empty, nil, otherwise let first char and rest string do. Okay. Can we pattern match to determine if the string is empty? Yes, you can pattern match determine string is empty in Clojure. Here's an example. Okay. Match match as true. Let's see if that's true. Getting a lot of syntax errors. Okay, maybe it's because things earlier on or something. Okay, doesn't like that at all. Unresolved symbol match. I think maybe Copilot's just making stuff up at this point. Or not Copilot. Yeah, match does not appear to be a thing. First of all, this is not even referencing Clojure, is it? Nope. Okay, well, that's not helpful. So we'll just search for Clojure, pattern matching on strings. Def multi-def method to dispatch an arbitrary functions. This is kind of cool. It's a macro to define functions with pattern matching, just like railing space and core.match. Vectorial, that's cool. So Clojure doesn't really have a whole lot of great pattern matching, it looks like, in the core library. So def multi service charge. No, that's not what I want either. Core.match. This library implements a pattern match compilation algorithm that uses a notion of necessity from lazy pattern matching. Okay. Well, we will avoid using that for now, and we'll just say, okay, so I think we can actually just do this within the valid here. We're going to say, if the string is empty, no, we need two pieces of information, right? We need the stack and we need the string. So we're going to say there's a function called defn. We'll figure out what to name it later. And it's going to take a string and the stack. Okay. And so what we're going to do is we're going to loop over a string. And we're first going to say, if the string is empty, if and is empty stack is empty string, then true. Well, first of all, we want to check to see if we want to terminate on just the is empty stack bit. Okay. So if the string. Okay, so if the string is empty and the stack is empty, then we return true. If the string is empty and the stack is empty, then we're to return true. If the string is empty and the stack is not empty, then we return false. And then finally, this is where we actually do a thing. Is empty doesn't seem to be. How do I check to see if it's empty again? Just empty. Empty. Okay. Now that's not correct, I don't believe. Well, it's not. This bit right here doesn't, needs to recursively call it now. So that's where the heavy lifting is going to happen. Okay. This doesn't look very Clojure-y way of doing it, but we're gonna continue on. So if I were to just say ASDF of string with an empty stack, and run tests, which not all of them are going to pass, but I expect some of them should pass. Oops, that's not what I want. Line test, I think. Okay, 7 failures, 13 tests. So 6 of them passed. Because it got to the end of the stack, the string, and because we just said the stack is empty, then just returned true. So what we actually want to do is we want to say, here we want to say let, this is where we can do that pattern matching bit. Let first char and rest s. String. Let first char and rest string. That's kind of cool. I kind of want to see what this does. So cond first char equals that opening one. Then we call with a rest and conjoin the stack with a closing parentheses. Basically, every single time every character that we look at, we should be taking a look at the stack, seeing if it's the corresponding match. The character that we're looking at is the corresponding match of the top of the stack. And if so, then we want to pop it off the stack and proceed. So we want to do let first char and rest string let top and, well, we can't call it rest. Do we need the rest of the stack? Guess so. Call it bottom. Top and bottom of the stack. We're going to say if the first character is a corresponding bracket to the top character of the stack, then pop it off the stack. And yeah, something like that. Let's see. How do I do this? I guess we can do a cond. There's probably a better way of doing this, but equals closing bracket well, we need the and as well. Okay, so and then this equals is also in the wrong place. Copilot has no idea how to do Clojure. Equals first char. Okay, select one more. And top is equal to the beginning. Then we pop it off essentially. So we do use the bottom there. Then we say ASDF with the rest of the string and with the bottom of the stack. So same thing with that, same thing with the parentheses. So else, what's going on here? This collection here, what does that do? I'm very curious about that now. So here we have first char, but if we did that, it returned, okay, so that's the thing that returns it if it is that correct? So nil, if it's in one of those things, then we return it back. So I don't think it matters if regardless of what character it is in the else case, we just stick it back on the stack, right? So I think we can just say else how do we do the else again? That is right. Else call ASDF. I can spit one of those out. Whoa, that's not what I needed. Magnifier. There we are. Okay. So cons first char onto the stack and then proceed with the rest. Yep, that looks fine. All the parentheses matching. We need one more closing one. Alright. Okay. Let's give it a shot. How do you feel working out? Three failures. Wow. 0 errors. Okay. So, which ones are not passing? Paired with white space, math expression, and complex latex expression are the three that are failing. So we'll take a look at what those tests look like. Paired with white space. Matching brackets is valid. Oh, okay. Okay. So it really should only be if it's a bracket, right? We don't care what's in the middle between them, so long as it's eventually closed. So if it's one of the opening ones, then we'll stick it on. And then finally this else clause will just say else ASDF rest stack. Yeah, that should be fine. One failure, okay. unopened closing bracket. Unopened closing bracket. Okay. So it's okay with an unopened closing bracket because the closing bracket wasn't let me think about why that's the case. So what happens here is it put these two on the stack. Then it found this guy and it put it on the stack. It should have put it on the stack, right? Well, it didn't put it on the stack. That's a problem. So do I just add those to there? Would that fix it? Closing of that one and closing of that one. Does that fix it? Hey, there we go. Okay. No idea if that's good code at all. Doesn't feel great, but let's see if we can find a formatter. I want to see what this looks like properly formatted. Control-Shift-P. There we go. Format. Calva format. Format current form. Okay, so this is what the recommended format should look like here. Okay, not bad. We'll rename this to what do we want to call it? Loop string. Or do we want to call it validate? Do that. Validate. Okay, good enough. Still passes all the tests, hopefully. It does. Okay. Submit that then. So again, no idea if I'm doing this the Clojure way. Not sure what the Clojure way is, but it works. I think it's logical. The idea is essentially we're keeping track of the parentheses on a stack, and we want to make sure that by the time we reach the end of the string, the stack is empty, which means that every parentheses had a corresponding pair. But because we also don't care about anything else being paired up, we only push parentheses themselves onto the stack. So, interesting. That was listed as a medium exercise? Medium. Okay. I think this is one of my first medium exercises that I've completed. Cool. Well, that brings us to exactly 33.3%. A third of the track complete, and that's it for today's stream. Finished up the 5 exercises for Summer of Expressions here. So I think I probably need to do a couple more to make the Summer of Expressions badge.